Welcome to this explainer. I am so incredibly excited to share this with you today because we, as astronomers, are going to investigate a literal frozen traveler. Just imagine a cosmic messenger that has drifted through the absolute freezing darkness of interstellar space. And we're not talking for thousands of years, or even millions, but for billions of years. Long before Earth even had oceans, long before our own sun ignited, this object was already wandering the void. Today, we're decoding the secrets of 3I/Atlas. It's the third confirmed interstellar object to ever cross into our solar neighborhood, and we're going to see exactly what it tells us about the ancient origins of our galaxy.
Okay, let's quickly run through the syllabus for our deep space investigation today. 1. A billions of years voyage. 2. Detection at Atlas Observatory. 3. Anatomy of an interstellar comet. 4. Spectroscopic and isotopic evidence. 5. Natural origin versus speculation. And 6. Next-generation interstellar surveys. Let's dive in.
Section 1. A billions of years voyage. Deep time in the Milky Way.
We actually aren't going to start our story at the observatory today. To really get this, we must journey back to the very dawn of our galaxy. Recent studies suggest 3I/Atlas is approximately 7 to 12 billion years old. It likely originated in the Milky Way's ancient thick disk, which contains some of the oldest stars in our entire galaxy. When you compare this to our relatively young 4.6 billion-year-old sun, 3I/Atlas becomes a vital tool to map galactic history. It's basically a surviving fossil. It's carrying frozen, pristine information from an era when our galaxy was in its absolute infancy, finally arriving at our doorstep in July 2025.
Moving on to Section 2. Detection at Atlas Observatory. A surprise in Chile.
Let's see how this epic billions of years voyage culminated in the exact moment our telescopes captured its light. On July 1st, 2025, astronomers operating the Atlas survey in Chile spotted an anomalous point of light. And the irony here is just fantastic. You see, ATLAS stands for Asteroid Terrestrial Impact Last Alert System. Its primary mission is planetary defense against relatively slow, local Earth threats. So the technical challenge here was immense. Hardware and software that were carefully calibrated for our local neighborhood suddenly had to intercept and process tracking data from a deep space interloper 670 million kilometers away. It literally wasn't supposed to be there.
And check out this blistering velocity. When astronomers first spotted it, it was moving at 221,000 kilometers per hour, and it was accelerating to a staggering 246,000 kilometers per hour as it neared the sun. To put that into perspective for a second, if you were moving that fast, you could circle the entire Earth several times in a single hour. Now, in astronomy, speed is a definitive fingerprint of origin. This extreme kinetic energy was the undeniable mathematical proof that 3I/Atlas was completely unbound by our sun's gravity. It confirmed its interstellar origins for sure.
For our student colleagues tuning in, we should quickly define exactly what makes an object interstellar. It all comes down to its trajectory. 3I/Atlas is on a hyperbolic orbit. Normal comets, they travel around the sun in closed elliptical loops, meaning they eventually come back. But a hyperbolic orbit means the object has so much kinetic energy that our sun's gravity just cannot capture it. 3I/Atlas is basically acting as a cosmic tourist. It's making a brief, high-speed flyby before continuing outward into the dark, never to return.
Section 3. Anatomy of an interstellar comet. Contrasting our cosmic visitors.
To truly understand this object, we really need to contrast it against the baselines we regularly observe. 3I/Atlas completely defies the profile of typical local comets. Our standard comets from the local Oort cloud are icy leftovers from the formation of our specific solar system, so they're roughly 4.6 billion years old and operate on closed loops. 3I/Atlas, with its hyperbolic trajectory and astonishing 7 to 12 billion year age, was forged in a completely different stellar nursery. This gives us an unprecedented comparative data point.
We also have to compare it to our very first interstellar visitor, Oumuamua. Remember that one? It was famously strange, showed zero visible comet activity, and honestly gave us pretty limited data. 3I/Atlas is thrilling because, much like our second visitor, Borisov, it exhibits clear, visible comet activity. As it heated up approaching the sun, it released internal gas and dust, creating a prominent coma. As an astronomer, this outgassing is exactly what we want. It pulls the internal chemical makeup of the comet right out into the open, giving us vastly clearer, superior data than we'd get from just a dormant rock.
Section 4. Spectroscopic and isotopic evidence. Decoding the chemical fingerprints.
That visible coma allowed our spectrometers to directly decode material from an alien planetary system. And looking closely at the spectroscopic data, the surprises are massive. Compared to our local baselines, 3I Atlas features unusually high methanol and elevated carbon-bearing compounds. But the real scientific treasure here, the isotopic signatures. Isotopes are basically atomic barcodes, and studying them provides a direct, unadulterated look at the environmental conditions of distant planetary systems. The exotic ratios found here prove it evolved under completely different chemical rules around an ancient freezing star. It's giving us unprecedented insight into early galactic chemistry.
Section 5. Natural origin versus speculation, addressing the theories.
You know how it is. Whenever an object with such unprecedented chemistry and speed appears, it inevitably sparks intense debate. When you combine an age of up to 12 billion years, a rare orbital geometry, blazing high velocity, and alien chemistry we've literally never seen before, human curiosity naturally runs wild. People began to ask profound and sometimes pretty wild questions regarding its true nature.
This all culminated in a fascinating public discourse. Some researchers, including Harvard astronomer Avi Loeb, rightly pointed out that highly anomalous objects deserve rigorous, open-minded investigation. This led some to ask, could it be artificial? Could it be alien technology? However, it's absolutely crucial to impartially look at the data we just reviewed. Mainstream astronomy's consensus is clear. There is no evidence to support the artificial conclusion. The exotic isotopic fingerprints we observed in its coma outgassing provide the irrefutable scientific proof needed to definitively classify 3I/Atlas as a natural, albeit highly ancient and unusual, comet.
Section 6. Next-generation interstellar surveys, expanding our cosmic catalog.
Understanding the true nature of 3I Atlas really forces us to completely rethink our approach to the night sky. The most shocking realization is that this is likely just the tip of the iceberg, because current defense telescopes like Atlas are stretched to their absolute limits just catching one of these. It means many interstellar objects are zipping through our solar system completely unnoticed. This highlights the absolute necessity for advanced, next-generation survey telescopes. We're standing on a precipice here. We are shifting from celebrating singular, rare discoveries to potentially cataloging hundreds, thousands, or even millions of interstellar visitors in the coming decades.
As we wrap up this explainer, we really have to reflect on what this ancient messenger has taught us. It proved our galaxy is far richer, stranger, and older than we ever imagined. But it leaves us with one profound question to ponder as we look up at the night sky. How many ancient travelers like 3I/Atlas are still out there, silently drifting between the stars, just waiting to be discovered? Thank you for exploring the cosmos with me today. Keep looking up and keep questioning the dark.